So, dear students, in this class, we are starting our first microprocessor of the course, that is 8085 microprocessor. So, first I'll be discussing the features of 8085 microprocessor. Then I'll discuss about the architecture of 8085 microprocessor, then its pin diagram, and in this way we'll proceed and I'll explain everything related to this microprocessor. So starting with the features of Intel 8085 microprocessor. So this microprocessor is an 8-bit NMOS microprocessor, that is, it can accept, process or provide 8-bit data simultaneously. That is, the word length of this microprocessor is 8-bit. It is a 40-pin IC package fabricated on a single LSI chip. LSI is large scale integrated chip. It operates on a single plus 5 volt power supply connected at VCC. Its clock speed is about 3 MHz and clock cycle is of 320 nanoseconds. It has 16 address lines, hence it can access 2 to the power 16 or you can say 64 kilobytes of memory. It provides, that is, this microprocessor provides 8-bit input output addresses to access. So therefore there are 2 to the power 8 or 256 input output ports. That is, it provides 8-bit input output addresses to access 2 to the power 56 input output ports. In 8085, the lower 8-bit address, that is A0, that is A0 to A7 and data bus D0 to D7 are multiplexed to reduce number of external pins, but due to this, external hardware, that is latch, is required to separate address lines and data lines. It has 8-bit accumulator, flag register, instruction register, 6 8-bit general purpose registers, that is B, C, D, E, H, L, and 2 16-bit registers. It provides 5 hardware interrupts, that is, they are trap, RST 7.5, RST 6.5, RST 5.5 and INTR. So there are a number of technical terms I have used while discussing the features of this 8085 microprocessor. So I'll tell about each and every term. I'll try to make it clear as we move further into this topic. So moving ahead with the 8085 architecture, the next topic that I will discuss is about its architecture. So as you can see, the 8085 architecture, first I will discuss about the register structure. Then I'll discuss each and every block of this 8085 microprocessor. So the register structure, starting with the register structure. Registers, why do we need registers? Why the microprocessor needs the registers? Basically, registers are used by the microprocessor for temporary storage and manipulation of data and instructions. Data remain in the registers till they are sent to the memory or input output devices. So the 8085 registers, 8085 microprocessor registers are classified as general purpose registers, temporary registers, and special purpose registers. Under general purpose registers, as you can see, we have B, C, D, E, H, and L registers. Under temporary register, we have temporary data register and W and Z registers. Under special purpose register, we have accumulator, flag registers, and instruction register. And next, we have 16-bit registers also, and they are program counter and stack pointer. So, starting with general purpose registers, as I've told you that B, C, D, E, H, and L are the general purpose registers. Again, I'm repeating the same thing that I've told you, that B, C, D, E, H, L are the general purpose registers. Program counter and stack pointer are the 16-bit registers. Temporary data register and W and Z registers are temporary registers, and special purpose registers are accumulator and flag register. So, starting with general purpose register, so B, C, D, E, H, and L are 8-bit general purpose registers. They can be used as a separate 8-bit registers or as 16-bit register pairs, that is BC, DE, and HL. When used in register pair mode, the higher order byte, that is most significant byte, resides in the first register. That is, in case of BC pair, the most significant byte will reside in register B, and the lower order byte, that is least significant byte, LSB, in the second register of the register pair. That is, in case of BC register pair, the least significant byte is going to stay in the C register. So these registers, as I've told you, this general purpose registers B, C, D, E, H, and L, they are 8-bit registers, means they can store 8-bit data. Moreover, they can also store 16-bit data when they are working in pair. Now, HL pair also functions as data pointer or memory pointer. It holds the 16-bit address of a memory location. These are also called scratchpad registers, as user can store data in them. To store and read data from these registers, bus access is not required, as it is an internal operation, as these registers are residing inside the microprocessor. So we do not need any bus operation for accessing these registers. The efficient programmer prefers to use these registers to store intermediate results than the memory locations which require bus access and hence more time to perform the operation. The next classification is temporary register, and in temporary register we have temporary data register and W and Z registers. So in temporary data register, as we know, ALU, that is arithmetic and logic unit, I have shown the architecture of 8085 microprocessor. This 8085 microprocessor is also having arithmetic and logic unit, and we have two inputs to ALU. One input is coming from accumulator and the other input is coming from temporary register. So this temporary register, okay, now I told you that ALU has two inputs, One is from accumulator and other from temporary data register. So this temporary data register is internally used for execution of most of the arithmetic and logical instructions. For example, let me take an example of add b. Add b is an instruction. So the purpose of add b is it will add the content of accumulator with the content of register b. So addition is done by arithmetic and logic unit. The two inputs that the arithmetic and logic unit will get, one input is from accumulator, the other input is from register b. So the register b input first will come to the temporary data register, and from temporary data register the second input will go to the ALU and the addition operation will get performed. That means the content of register B are transferred to temporary data register here. So this is the function of temporary data register. Now next temporary register is W and Z registers. These registers are used to hold 8-bit data during execution of some instruction. These registers are not available for programmer since 8085 uses them internally. The next classification is special purpose register, and under special purpose register first we'll study what is accumulator. So if you say accumulator or register A, both means the same thing. The accumulator is an 8-bit register. 8-bit means it will store 8-bit data only. So it is an 8-bit register associated with the ALU, that is arithmetic and logic unit. It is used to hold one of the operands of arithmetic or logical operation. So what is operand? You might have gone through the microprocessor lab programs. So you might have heard the terms opcode and operand. So as in the previous slide, I showed you an instruction that is add b. So add b, what it does, it adds the content of accumulator and register b. So what are the operands here? Operands are the content of accumulator and register b. So operands are those on which the operation is going to perform. Here the addition operation is going to get performed on the operands. So the operands here are residing, that is data which are residing inside accumulator and register b for this instruction, add b. Okay, so accumulator is used for storing one of the operands of an arithmetic or logical operation. It serves as one input to the ALU. The other operand for an arithmetic or logical operation may be stored either in the memory or in one of the general purpose registers, which will later come to the temporary data register for the operation purpose. The final result of an arithmetic and logic unit is also placed in the accumulator. There are also some logical instructions which need only one operand which is held in this, and that operand is held in the accumulator. So next is instruction register. I'll discuss later what is instruction register. First, let me discuss what is flag register. So flag register is also called program status word. It is an 8-bit register in which 5 of the bits carry significant information in the form of flags. That is sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. The Intel 8085 microprocessor contains 5 flip-flops to serve as status flags. The flip-flops are set or reset according to the conditions which arise during an arithmetic or logical operation. So starting with, let me end this class here. In the next video lecture, I'll be discussing all the 5 types of flag, and we'll move ahead with the architecture. I'm ending this class here. Thank you.